Hello, everybody. Before I start the talk, I just want to have a quick poll so that I know where everybody stands at. And then, because I'm going to be using finance portfolio as an example throughout the talk, I kind of want to know if you guys already know about it. So how many of you have heard of YUI app framework before? Awesome. Hey. OK, so how many have you have actually used it in your project? Wow. Great. Awesome. And now, how about financial portfolios? Have you guys ever had any? And all right. OK, so it's time to start having a financial portfolio. So even if you haven't had any, have you ever had your ESPP or E-Trade or whatever, where you're logging, you'll see that I have total value of $10,000. If it's 1 million, it's good for you. You have like probably 500 Google shares, 300 Yahoo shares, that kind of stuff. So that's what a financial portfolio is. So now, how many you have used Yahoo Finance? Ah, cool. Now, people who have not raised their hand, try it. And also, we have portfolios application on our site as well. So the topic of this talk is Mjata.js, bringing your data models to life. So I guess I put a mint leaf there, and that's a hint. And who can guess what it is? It's what Mjata means. So Mjata, the word, Mjata is not a car. It actually means mint in Ukrainian. I'll tell you more story about that if I have time later. So I'm LIngyan. I'm from Yahoo Finance. So let's start with this. So frameworks come and go, applications come and go. What do I mean by that? So essentially, if you have worked on any web applications, especially using any MVC in your applications, you would have heard many frameworks, right? Backbone, Angular, Ember, Mojito, Media, new things come out every year. And why do we need these frameworks? So essentially, we want to use these frameworks to build applications. So this is, but unfortunately, just similar like frameworks, applications also come and go. So like if you have an application you created a year ago, now because you need a revamp, you need a new features in there, and then you add more stuff into it, and you might even actually evolve into another application. So this actually makes us wonder. So in this fast-changing kind of field, in this fast-changing kind of world, what can make us more adaptive to this? Meaning that essentially what can make our life easier as an application developer, right? So so basically, when we started a new project this year at Yahoo Finance, before we started before we look at all the frameworks out there, and we decided that we want to sit down and look for the most cornerstones of what you need for application. So one of the cornerstones we come up with is basically data. So you have your application, and then people use the application to do what? Essentially, they use the application to mostly interact with their data, with the data, to consume the awesome data and awesome content you provide to them. And they even actually put in their own data, right? Create their own data in your system. So data has many characteristics. So for example, some could be simple and others could be complex. And there's free form, there's highly structured data, and there's static data, which don't change probably once after created, or they only change once a year, once a month. And there are dynamic data, like the data changes every second. And also there's stable and constantly evolving data, and then there's also many other things. So basically at Yahoo Finance, we deal with a lot of data. I mean really a lot of data. So just by stock tickers, option tickers, there are like almost 4 million tickers in our system. And then these data that comes in every second. If you have used Yahoo Finance or any other finance product before, you will see you can stream data in, right? So you can see Yahoo now it's 18, well it's 1801, 1804, and it's pretty exciting. And also we deal with highly structured data. And other things. So and the other challenges you normally will face is if you're working at a company that has kind of some years of history, And then you have been, you probably have been dealing with this. So you might have to support multiple tech stacks and frameworks in production simultaneously. And if it's not an issue for you, that's great. But within 5 years, you will see that coming. So you deal with the legacy, something becoming legacy, and something's current. And at Yahoo and at Yahoo Finance, we also need to be future thinking, look forward for what's coming next. So that brings us to this. So what is the most common denominator here, right? And because the most common denominators usually don't change that often. So as part of that, what we decided on is we actually truly wanted a library that focuses on the data, like data modeling, data interaction, meaning that you have data interacting with each other, and you also have data interacting with the page, for example. And also we want to make sure what we build is agnostic to the presentation frameworks, whether it's MVC or not, and even environments. So here, as Mjata means mint in Ukrainian, it's because we have a team that have team members from all over the country. And when we wanted to have a code name for our project, we were like, want to be mint, not come up with all localized version. And the Ukrainian one sounds the best, so we picked it. And there's another reason why we picked it. So it's actually, I wouldn't tell you now, but probably later. So the first focus is the data modeling. So we have a lot of data, if you remember. We have structured data, we have dynamic data, we have complex data at Yahoo Finance, and probably in your project as well. So what is the best way to model it? So actually what comes to us was the YUI app framework. We're really happy that YUI already had this offering there, because it really truly helped our life a lot. So YUI app framework is a roll-up of 5 components. So app, model, model list, router, view. And it should be no surprising to you because our library is focusing on data. We're actually focusing on using the model and the model list. So we use view a little bit in our applications, but primarily our library is built on top of model and model list. So a model is a class that manages data, state, and behavior associated with an application. This is truly important because before we had MVC, so all the states information is intertwined between your JavaScript and sometimes even CSS and your markup. And now with the model, you have this clear separation of concern that you put all the data, all the states in your model, and then the view becomes stateless. And everything is in there in a model in a way that your JavaScript code understands. So YUI model already has these attributes, what Luke has talked about in the morning. It has events, which is an awesome thing. And it has a sync interface, which is very easy to understand because it just inherits CRUD for create, read, update, and delete. And above that is also the model is just a perfect place for host business logic about data. And also the good thing is that YUI model is really easy to extend. So in this next couple slides, I'll just show you a quick example of how YUI model works, because I see a couple people have not used it before. So this example, I just got it from YUI site. Basically, what you're doing here, the Y.base is the cornerstone of most of for YUI. So use Y.base to create a model called PyModel based on Y.model. It's a base class. And I've intentionally left two blank spots here. Whoops. All right. First time clicker. So the first block is basically where you put your property, the extensions, right? Your methods, prototype methods on there. And the second block is where you declare the static methods and properties. So this is how you specify there. For my PyModel, I want to have 2 attributes. One is called slices, one is type. Each has a default value. So I'm going to have, by default, I'm going to have 6 slices of apple pie, basically in this case. And then you can add prototype functions there. Say, I want to eat a slice. And all that does is say, no, okay, then I'll get the slices, the current slices number, and decrement by 1, and then set it back to the slices. Now just ate 1 slice. So that was the class we just used YAF-based to create. We created our own Pi model class, and this is how you use it. You create now I'm using that to create a pecan pie, and then I can even hook up events to it, saying after slices change, let me know. And then now you can eat a slice, and you can even do things like I want to load more into it. I want to load more from Costco, for example. And this turned out to be a really good starting point for Mjata, because at the beginning, we actually before we knew YUI app framework, we almost started writing our own data models, and realized like, crap, there are so many things we need to work on. And then it's like YUI, awesome, we have it. So that was how YUI model, the basics of YUI model. So now from this slide, I'm going to show you how we use it at finance. So this is an example of finance portfolio. I kind of described it a bit at the beginning, but this is the diagram for you to probably easier to grasp. So finance portfolio, in a typical finance portfolio, you're going to have an ID, you're going to have a name, it's like my first portfolio, and currency, and a list of entries, and a total value. And each entry contains these fields, like a quote, a share, like how many shares I've bought. Like I bought Yahoo for 100 shares, what's the cost basis, and so on. And the last one is the value, because each entry has a value, right? So like multiply your current price by the number of shares you've got, that's your value. And each quote is actually a symbol, like Yahoo, in Yahoo's case, YHOO will be the symbol. And then you have last trade price, last trade time, day value change, and 100 plus more. So you can see that this is already an like overly simplified example I've just put up here for the presentation, so then you don't have to stare at hundreds of many fields or attributes. So there are so many attributes, and there's nested models. There are like relationships between these models. How do we manage that? So if you think about just go with the YUI model, we had that beautiful ATTRs, right, where you can list out all the attributes you want to declare. But in the case of quotes, you have 100. How would you do that? You're going to write them all by yourself? No, you don't want to do that. So what we introduced here is the Mjata schema, which helps you. So which is basically a JSON file, and it happens to be using a JSON schema. So JSON schema is already a published thing, kind of standard out there. And the step 2, then Mjata.js will actually automatically generate attributes. So that the huge attributes block, you don't have to write it yourself, unless you want to customize certain methods. So it will generate things like default values, validators, and even relationships for you. So these have stars there is because we're still working on those, but this is the goal we're gonna do. And plus, well-written schemas and also actually enable very easy data exchange between partners. So for example, Yahoo Finance has a portfolio, and then the homepage saying, the Yahoo homepage saying, okay, now I want to show finance portfolio on my page. What would I do? Now with this, it will really help you a lot. And it's easier for the other properties engineer to understand our data. So this is an example of the schema. So I said it's a JSON format using JSON schema. So don't worry about the fluffy things if you haven't used JSON schema before. But the idea here is that this is a portfolio, and then type as an object. And these are things, if you remember in the diagram, we have the ID, name, currency, attributes. And you can have a list of entries. So there are little subtle things I'm not going to go through in depth today. It's like the reference, how do you reference to another model, like that kind of stuff. So, but basically the idea is you put a schema in a JSON file, and you publish it, and you also use that to generate a model class. So now you have the schema already defined. This is how you create a model class. So instead of going Y.base, do everything manually, and we have something called model-base, called create model class. And these should be very familiar if you have used Y.base before. So you have portfolio name, version is something we added because if you remember, one characteristic of data is actually it's evolving. It could be constantly evolving. So that's why we have a version in there, so to keep different versions of model possible. And then this is the key. So by providing the schema object here, it will know to go to the schema you have defined and then pull those attributes in automatically. And by the way, the schema is actually optional, so you don't have to use it if you have really simple schema. And now, so we have got our model, we have defined our schema, we've got our model class. Then how does the model get data? So that's a flashback to YUI for a little second. So YUI model sync layer already has these things defined. So they have 3 public methods called load, save, destroy, which internally called sync function, and which takes 3 parameters: action, options, and callback. So actions is either one of the actions from prod. And then when the data comes back, it's going to call the parse function, and then set it to the model through the attributes. So the sync layer is what applications supposed to customize for actual data syncing. So in our case, so I guess like if you're just using YUI model for simple use cases, there are already sync library out there provided by YUI, and there are also a couple of gallery modules out there. But in our case, we actually put in something called Mjata service and Mjata store. The idea behind this is that just using the gallery modules or using the already provided the built-in sync layer, it's easy, but it doesn't really give you a lot of like abstractions that we really want. So in this case, for Mjata service, we have a data service layer. Then behind the service layer, you have a bunch of different stores. You can have a web service API store, whether you're getting the data from your REST API or from your YQL API or whatever, what have you. And you could configure a cache store for it. So it could be a local storage, it could be memcache, it could be Redis or anything. And you could even have a mock store, which helps with the initial development when the API guys is not ready, and also helps with the unit testing. So it's actually, so I put the 5 things down here. It's actually the benefits of this as well. So first of all, we provide the abstraction. So it really abstracts the nitty-gritty details of all your stores. And it provides a very stable interface for your library user. So for our application developer, they don't really care if you have a new store coming or in a month or in a year. It doesn't matter, because for them, all they interact with is the service if they choose to. So you can swap in and out stores easily without interrupting your upper layers. And also the reusability. And the other 2 things we also added to the feature is the request consolidation and building data flow. So example of that would be if you have, for example, for the data flow, if you're reading data from a remote place, and when you call data to the data service, if you have a cache store configured, it's going to try to read it from cache store first. If it's a hit, if there's something already in a cache, then great, it's going to return right away. If it's a miss, it's going to go out to the remote store, get data, and then put it back to the cache and return to the user. So we use the same CRUD, and we add a stream in their interface. And one thing I just want to emphasize is also that the data output from these services and the stores will already conform to the model schema you already defined in the JSON schema. And this way, it's really cool, because in this way, then the user can pick and choose to what they use. So if they want to use the model, they use the model. If they want to use the service, they use the service. If they want to use the store only, they use the store only, because it's all same interface. The same data format comes out, right? And also, it matches YUI model's sync CRUD interface perfectly, and it's perfect for server side. So speaking of server side, so that brings up the questions: do we really need data modeling on the server side? So we actually started off with having data models on the server side, because we're initially using Mojito. They have the models on both server and the client side. So we just use model on server side. But turn out, it's using model actually probably brings more overhead than benefit for server side execution. So what do you mean by that? There are a few things. So first of all, events is great on client side, but it's not needed on the server side. So on server side, you usually just get data from the store, from the remote data store, and then zap that into your template and produce the markup. So the attributes could also be a little bit heavy. You've heard that from Luke this morning already, right? And instantiating model objects for each request also could be wasting your CPU and memory, especially under high load. Think about Yahoo Finance's servers, like thousands of requests per second, and you can't do that. And also the model store, when you actually feed the model store data into the most template engines, it will require you to do a to JSON first to convert to a JSON object. And that could cost you time. So what we have seen during our development was that depending on how complex the model is, it could go from 1 millisecond to 100 milliseconds or even more. So the one benefit we lose by not having model on the server side is the business logic. But what can we do by that? So how can we work around that? It's basically what we found is that we use the YUI plugin. You can group your business logic into these plugins and plug into either a model object or a JSON object. So this is something you can do actually. If you haven't done it, you can play with it. And also, good news is YUI team is also working on a more lightweight model-based class, a model core class. So once that comes out, we will go back, check it out, and reevaluate this. So that was all about data modeling. So the second focus of Mjata is basically on the data interaction. So as I said, the data, very commonly, data needs to interact with each other, and also data needs to interact with the page. So how do we use and interact with the data? So the first thing we come across is the model sharing. So if you have worked on a single page application, then you will find out you'll have different modules on the page, right? And then most often than not, these modules will need to share data underneath. So this is an example. This is just a module on finance, Yahoo Finance's front page. So you have we call this recent quotes module. And the most important thing here is this is the list of tickers you have recently visited on Yahoo Finance. So we keep a list of it for you, and then we show you the price changes, today's chart, and also we show you all the latest news for these tickers. So if you just look at these modules, you will find out, and they're sharing data, right? They're sharing the list of tickers they're sharing. And another example, a little bit more complex, is on the finance portfolio side. You will see a page like this. This is a page basically showing you your portfolio. So one of your portfolios. So the center of this page is the table of all the entries you have in your portfolio. So I have all these 4 companies in there. And then similarly, I have recent news for all these tickers. And then you have a total value for your portfolio, because I want to know how much is the total, right? And the last box here is actually, it's interesting. This is something you can enter a symbol you don't have in a portfolio. And once you press that add symbol, what do you expect to happen next? It's going to add that ticker into this table, add the ticker into here, and potentially change the value there, right? So this is you can see that how these models do have to share data and to have to interact with the data simultaneously. So the way we did it is basically, because we look at the YUI app framework, we didn't find a built-in kind of functionality for sharing models. So we went up building both a model store. So it's a simple interface. It's just called dmodel with some parameters, or dmodel with some parameters to get a singleton model instance back. And then from now on, all the modules, doesn't matter where am I on the page, and I'm just going to use the same interface to get the data back. And model store will take care of the rest for you to make sure that the instances are shared. So there are 2 attributes in here, 2 parameters in here. One is the attributes. So this is not a surprise for folks who are using YUI model. It's just like an JSON object of your attributes data. And the reference is something we used in the model store to uniquely identify these model list instances. So this is just, we added a system ID called SID, stands for scoped ID. It's just to make sure that the ID is guaranteed to be unique across the globally application. So now you have the interface. This is an example of how you use it. So you have the reference. I want to have a portfolio model. This is my ID. And this is the attributes from my portfolio. The name is my portfolio and a bunch of entries. And this is how you get the model instance object back. And then now I have the instance. Then now you can call load or any other function you want to. You can even add events to it. So if you look at from this, you can see this, as I said a couple minutes ago, it really enables complete model decoupling within your code, module decoupling in terms of getting data, getting the model. And just one thing here, you can notice that registering events, it's cool, but it could be a little bit cumbersome, right? Because you have to get all these models, or you create your model, and then hook up these events all manually by yourself. So what we did after we had the model store, we discovered that it's really cool because now we have a central place to play with the model, and also this turns out to be a good place to delegate the model events. So for example, this is something we did that on the model store, you can just do an on to listen to any events, the portfolio model events. So if you have used the YUI attribute model, then this syntax you should be familiar with that. It's just the name, the model name plus the attributes you're interested in. And can hook up after event for a model list. So when you add a new model to the list, let me know. And guess what? It was really easy to do, extremely easy, because YUI already offered the event bubbling mechanism. Just by one line of code, add target to it, and then everything is there. So this is the beautiful thing of using a library you already have. Otherwise, I have to write all my events handling, pops up, all that kind of stuff, right? So the next thing I want to talk about is the inter-model communication. So this is an example of, let's go back to the portfolio example. So you have portfolio, have list of entries. Each entry has a symbol. So now let's say, now it's 10 o'clock in the morning. The finance market is open. And your Yahoo, you had a Yahoo stock for 500 shares. And now just the last trade price changed from 17 to 34. Wow. OK. So once that happens, what happens, guess what? So we have, our value has to change, right? So our portfolio entry value has to change, because now all of a sudden your entry value has doubled. And when that changes, what's next? Your portfolio total value has to change, right? So also these models, they're there, and also they have to interact. So that's what we mean by kind of bringing the model to life. So how did we do that? So you could manually set up everything by yourself. And what we actually did was, it's truly inspired by the YUI app framework's y.view. In the YUI view component, there you can have something called declarative model, like event mapping. But in that case, it's particularly mapping your UI events. So in our case, we actually borrowed that idea. So we use that same mapping for model events. And this is an example. So how does, for example, for the first one I mentioned in that chart, in a diagram. So when last trade price changed, how did that propagate to the entry? And this is the portfolio entry model's prototype. So this whole thing. And what we did is inside the prototype, we added events. So in the events, this is what you do. So because of time, I cannot dive into the actual syntax of it. But the spirit is that in this now I can say I'm interested in quote model events. And what kind of quote, specifically after last trade price change, let me know. Then I want to invoke this quote changed function inside my model. So then by doing this, it made the first error possible. And for the second error, it's very similar. So just how did when the portfolio entry value changed, you want to propagate it to the total value of the portfolio. And the same thing, you have events in your portfolio model, and you say, I'm interested in the entry model change. So when value changes, tell me, I'm going to call my event entry value changed function. And in this, you can calculate the total value. So that was about how we take care of interaction between data. And the next thing is also about interaction, but this time it's about how to interact between the model and your page, your DOM. So if you have looked at any like JavaScript MVC framework before, and a lot of them have offering for data binding. So we also have that. So for us, we actually focused on model to DOM one-way binding because we feel that benefits us the most. And model to DOM binding enables automagic updates to the page's DOM when underlying model or model list changes. It's very cool because it frees up app developers to focus on developing the actual cool features you want to add. So this is how we did it. So we have Mjata.js implement. We did through the HTML5 data attributes, just like any other data binding will do. And we do it through 4 attributes: data list, data model, data attribute, and data template. So data list it binds the model list instance to the DOM element, and this is a syntax for it. It's if you recall, there was a reference when we were trying to get the shared model instance from model store. We use these, right? We use this. It's the nom. This is a name and then it's scope ID. So here to say name is this and it's scope ID, and then it will, because these are unique identifiers for us to pick up the instance from our model store, and this allows binding to find that, to locate that model list instance. And same thing for data model. So data model binds the model instance to DOM. And data attributes is basically you can bind a particular attribute. So data-attr equals the name, which is the name of the list attribute. I'll show you an example of this. And the last thing, this is more powerful than data attributes, but it's also a little bit harder to understand, maybe. Actually, it's pretty easy to understand. So data template is basically something you can bind a template to your model or list events. So it's agnostic to template engines. So we have tested with handlebars thus so far. So in this case, here you can see data templates. You can have a list of these things, and then you have model list event points to a particular template name. So in this case, this will be something you put on a portfolio model list instance, and you can say when you add a new model to the model list, I'll call the portfolio. I'll use the portfolio template. And when you call reset, when you reset the list of reset your list, we'll call the portfolios. So actually, this is an example markup of, and also a showcase of how data binding really saves our life, or saves our time with their life. So for example, like deal with the stream quotes, like remember we said like at finance the data comes in it's just when the market is open, the quotes stream thing like every second, many quotes coming. So in our old system, it's really hard to hook up the streaming. It's very error prone, and now with this, it's made it extremely easy. So we could just do something saying the data model equals to this particular datum. I care about the Yahoo price, and this is the attribute that we have formatted in raw data. So, and this is the value. Just by doing this, when stream data comes in, all you need to do is update the model itself. So when the model data updates, then it will automatically replace this with the new 34 number in this case. So similarly for your changes, so we're up 100% today, and then that. So another example of the using template is one thing I didn't call out is that so by having templates is really cool because you can actually share templates on both client side and the server side. So this is an example of how you do the using template to update a model list. So I've already mentioned that it's agnostic to engines, to templating engines. Now the last main focus I want to share today is that we truly, when we started building this, we want to make this agnostic to presentation frameworks and environments, because things change too often. We are not God. We cannot predict what's coming next. So particularly frameworks, in this case, we have tested with Mojito, which is Yahoo's open source presentation MVC presentation framework. We've tried it with the Express app. We tried with pure client side. And also on environments, Node.js, browser, and mobile. So that brings to our summary. So the focus, so basically for when we worked on this library, we had a laser focus on the data, so especially on data modeling, model sharing, intermodal communication, and data binding. And we built with supporting various frameworks and environments in mind, because this is very important. It turns out to be, we are really happy we did this from the beginning, not an afterthought. And YUI app framework truly provided us a solid foundation, because with what they have provided us, it's kind of, we don't have to care about those heavy lifting part. So all we need to do is adding more things we need on top of it. And this also, this whole talk is basically a showcase of how much can be built on top of YUI app framework. So I think you should be encouraged now to start trying things on your own, then to add more stuff, more cool stuff to it. So these are the references we used. And thanks to two awesome teams, the finance Mjata team and YUI team, especially Eric and Ryan for their YUI app framework work. And just open for questions. And plus, my manager forced me to put this on there. So Yahoo Finance is hiring big time, and we're looking for the smartest engineer. Doesn't matter if you're application engineer, backend, or front-end engineer. We want every bit of you. So thank you for your time.
Yeah, I was wondering when this might be available in the gallery for external contributors.
That's a great question. Actually, it's a great reminder for me. So the thing here, sorry about this, it's kind of, we haven't open sourced this yet. The part of the reason is because we're building on top of YUI. We kind of want to talk with YUI team, first of all, to see if there's any components they're interested in. And if they're interested, then it's better to put them into the base library. And for the other pieces, then we'll think about putting into the gallery, or even, or other open source ways. I think the one primary thing is another thing of giving this talk is kind of I want to kind of get a feedback from you guys to see how much useful you think this will be for you. So do we really want to, should we really open source this or not? Because we don't really want to open source something that really people don't care about. So if you think you might be interested, raise your hand. Cool, hey, better than expected. All right, so if you will be interested later on, you can always email us. And we're open for any suggestions or feedbacks. But if you want to use it offline, we can talk about it. Yeah, I think a lot of this, they're not rocket science. So most of these are really showcase of the ideas of what you can put into the system to make your truly industrial production site function better and make our lives easier.
Do we have any other questions?
There's one.
Hi, I was just curious why on the binding to the DOM bit, was there a reason that you didn't use y.view? And on the models talking to models bit, again, whether there's a reason that you didn't add target and sort of use the custom events from one model to its parent, if you like.
Also so let me answer the first question. So for the view, I know that you can have, each view can have a model or maybe more models, and then you can set up your models events that way. You can say, I'm interested in this particular model, and then this is what I want to do. So basically what we do is, also view is another place that if your user has changed something, then you can say, go ahead, go back to change the model. So in our case, essentially, if you think about these are two different tasks, right? So for us, we kind of want to make the first part of this easier, but by providing automatic update to the DOM, just by having when you have model changes through these markup annotations, automatically reflect them. And for the other part of the other way of binding, which is from the UI events to the model itself, we felt like we didn't want to focus on that first. And also the other thing, we felt that UI events are has more variety, basically, than the model events. So model events is pretty limited set of model events. And also the UI events, because of lack of things like when something changes, for example, when content changes, I want to update my model. And there's no good cross-browser support for that kind of events. That's why we didn't want to focus our effort on that. And for the second question of why do we do the events this way? So for the linking the models up, because we actually feel like this is declared in your events inside a model is actually better by writing the code, spaghetting your code to do that. For example, if we didn't have that, then you will have to say when my portfolio model changes now, or like in the portfolio model, you're gonna have to say now get all my entries, all my portfolio entries. I'm gonna I'm going to register an event on each entry. And this is OK, but then once your entries change, you have to do it manually again. So basically, in our case, we use the event delegation, and also by doing the declarative, the event mapping, it's actually one place you can. It turns out that events block is one place you can see all your event hookups. It's really easy for you to maintain, and also to trace your code.
Do we have any other questions?
I guess it's similar, like why does YUI view has an event mapping? Yeah.
So do you use the data store? So in order to get the streaming changes, right? So do you use the data that's stored in the media store to pass that portfolio back to the server to get the data, or?
So in the case of streaming, what happens is that we have, so for that service layer diagram, so we have a service layer on top, and then we have multiple stores behind. So imagine this is one unit. For a portfolio, you have a portfolio service. And for the quote, you have a quote service. So you have multiple of these for different kinds of data, the semantic logical data, right? So for the streaming, what happens is that we have a quote, we have that unit for quote. So we have a quote service on top, and then underneath it, we have a stream store. So this stream store actually takes care of open up a channel with the backend to get whenever the Yahoo price changes from 17, 18, 19, whatever, and you just go through that stream store and bubbles up to the service layer, and eventually be fed into the model layer. So for the streaming, for example, right now we only support one protocol, but we're actually expanding that to supporting more protocols. But the idea of having the store is that today you can use my crappy old stream store. I have the streaming protocol I have had from 5 years ago. But tomorrow when I have a new one, I can just plug that one in without interfering any with like my upper layer users. Yeah.
Do we have any other questions?
In storing the data for the models, is it all stored In storing the data for the models, is it all stored actively in the DOM, or is it cached in things like local storage?
So right now, the data is actually, so we don't really scrape down for data anymore. So the data is actually stored in the memory for now. And then what we're adding next is that we will think, so because you are storing all these things in the model store, right? You have to think about garbage collection, that kind of stuff. So what we want to add is have a mechanism of saying, this model hasn't been used for a while. What we're going to do is we're going to swap that data out from the memory into potential local storage as a cache. So just like you have RAM, you have memory, and then you put it into L2, L3, that kind of cache. So that's something we will be doing. But the key is on the client side is that when you just fetch data for the data you use often, where you put it into memory, and then if you don't use it anymore for a while, we push it into the cache, push it into a local store cache, and then if that doesn't use after a day, for example, we just wipe it out.
Okay, do we have any last questions? Okay, can we give a big hand for LIngyan?